Good afternoon. My name is Dale Brocious. I'm the Chief Commercialization Officer for IACME, the Composites Institute in the U.S. This is the session, Steering the Future of Ground Transportation with Composites. So if that's not the session you were planning to attend, stay anyway. You'll be very entertained. So just to make sure you're not at a session that's just going to talk about electric cars. In fact, we're going to be talking about everything but electric cars in this session. So I want to we're looking at unconventional modes of transportation. So the first thing I want to do is invite our three panelists that you'll be hearing from to come to the stage. So you'll be hearing from each of them in starting just a couple of minutes. But first, we have to pay the bills, so we have to thank our sponsor, the Michigan Economic Development Corporation. Today, to make an introduction and to show a video, is Bob Metzger, the Strategic Engagement Director for the Michigan Economic Development Corporation. Bob, would you please come up?
Greetings from Michigan. At the MEDC, we are proud to sponsor today's Steering the Future of Ground Transportation with Composites session. My name is Bob Metzger, and I work at MEDC. For more than a century, our state has been focused on transportation, innovation. This session is focused on composites' role in the future of transportation. And as transportation evolves, Michigan has a responsibility to help drive that evolution and the opportunities and potential that it can offer for all of us. Composites offer vast potential for innovation and collaboration, and at MEDC, we succeed when you succeed, by helping you succeed. So, if you need suppliers, partners, research, facilities, access to capital, or one of the best manufacturing workforces in the world, Michigan is ready to help. Thank you very much, and I'd like to ask for the video to be played now.
A culture of innovation that put the world on wheels and is now driving the next generation of transportation technologies. A legendary workforce that powers a statewide arsenal of innovation. A dynamic entrepreneurial ecosystem that captures the world's imagination and transforms concepts into creations. Vibrant communities and abundant natural resources that draw visitors from around the world, offering an unparalleled quality of life. For growth-minded companies looking for the right business environment for expansion or relocation, Pure Michigan means pure opportunity. A global supply chain located within 500 miles of 50% of the U.S. population, with direct access to Canadian markets via 3 international border crossings. Access to the highest concentration of engineering talent in the U.S. and a skilled workforce among the top in the nation for advanced manufacturing. A statewide support network for startups, entrepreneurs, and small businesses, with a technology sector among the fastest growing in the country for annual tech job growth. The global epicenter of mobility innovation, ranking #1 nationally in automotive and mobility research and development. An international destination for foreign direct investment from across the globe. Historic downtowns and dynamic cities where people want to live. Combining a cost of living among the lowest in the country with a quality of life among the highest. When it's time to plan for what's next for your business, discover Michigan and discover pure opportunity.
Thank you, Bob, and thank you, the MEDC, for that presentation and for sponsoring the conference. I can speak that I know Michigan very well, lived there 20 years, and everything in that video is true. So we're going to move on to our first speaker, and all three speakers are going to present. Then we'll open the floor to questions and some dialogue about the future of ground transportation. But we're not going to move far from Michigan. Our first speaker is Sebastien GENDRON, the CEO of TransPod, based in Toronto. And so, Sebastien, the floor is yours.
Thanks a lot. Sebastien GENDRON, CEO and co-founder of TransPod. So we are a Canadian company. We're based, like you said, in Toronto, and we also have activities in France, in Limoges, and we just opened last year as well a subsidiary in the Middle East, and working in Canada, of course, and developing projects in the US too as well. So we'll go through a presentation showing what we do and what we aim for in the next few years. So our vision, it's an ambition one. It's definitely to create a transportation network, a new transportation network similar to what the railway sector started to do more than 100 years ago, but like kind of the next generation. And to do that, we're talking about the fifth mode of transportation after car, trains, boats, and airplanes. And of course, if you have to reinvent a fifth mode of transportation, it has to be better than what we have today. Otherwise, there's pretty much no point. Some of you may have heard about tube transportation or Hyperloop, that kind of the idea Musk popularized a few years back. But I have to say that we're slightly different. What we're doing is working, and we already have a commercial contract as we speak. So what are we talking about? I'll share with you a small video. Maybe we can dim the lights so people can see. This is the first demonstrator we unveiled in Toronto last summer. So it's a third of a scale of the full-scale vehicle we're developing. This is the full-scale vehicle. So it's a 25-meter long, I would say, vehicle. It's an aircraft without wings. This is the passenger configuration. You can see that. We also have a cargo configuration. The layout you're going to see here is similar to what we have with railway stations. This is the front door you just saw closing here. Since the concept is to have vehicle traveling in a tube where you have removed most of the air, doors are not on the side, but definitely front and back. And just to share with you a few ideas on or a few remarks on the concept. This is not something new, even if Musk popularized it a few years back. This is something which is 100 years old, and the concept consists of removing most of the air in the tube. So we're talking about 100 Pascal in the tube, so close to zero. So the vehicle can, I would say, you prevent the vehicle to have aerodynamic friction, and you can achieve speeds similar to an aircraft. What you just saw is the vehicle entering into an airlock, where before you had the atmospheric zone, and it's entering now into a low pressure zone where the vehicle will accelerate. What we demonstrated last year is really on the first demonstrator is the critical subsystems, and I'll explain briefly how it works. The critical subsystems are the power transmission, the levitation, and the propulsion. What we decided to do a few years back, it's not to go with a traditional maglev system because it's too expensive, but to have all the technology on the vehicle to keep the infrastructure as basic as possible. So all the tech is on the vehicle. So power transmission you just saw is similar to what we have on a subway. So you have a power rail and then a pickup shoe, except that it's frictionless. You have no contact. And what you just saw here is the levitation and the propulsion system. The levitation system is located at the top of the vehicle. So we're pulling the vehicle up thanks to electromagnet. And the propulsion system is similar to linear magnetic engines, which already equip some existing train today. It's a guided system. Here it's measuring in real time the circumference of the tube to measure all the deviations and anticipate those deviations to maximize the passenger comfort. We're talking about an elevated infrastructure. It could be underground or at ground level. It's really depending on the geography you're going through. If you have the Alps to cross, you definitely need to dig tunnels. And what you see at the end here is that to address also visual pollution, the objective is definitely to kind of get trees around that and some architecture design to address that. Now we'll discuss about composite. So, as I mentioned, it's an aircraft without wings. So lots of composites here, similar to what we do for the aerospace industry. It's from the initial feedback, most of the fuselage will be done in composite. To be energy efficient, we are running into the same challenge as the aerospace industry, since we need to be lightweight. Front and rear door, levitation system at the top, power transmission on the side, and then the propulsion system at the bottom. Similar again to the aerospace system, inside we'll have pressure bulkheads, and the interior we're looking at similar configuration that what we have today on airplanes. And for the cargo, same type of containers that what we have on airplanes to minimize handling activities between the airplane and the FluxJet vehicle when we transfer the container at the airport level. A few words on the infrastructure from what we saw, just as a summary. So stations, just picture that as a similar configuration as we have for railway stations. Then an atmospheric guideway before entering the airlock. Airlock where all the pressure, 99% of the air will be removed, and then you enter into a low pressure tubes where the vehicle can achieve speeds up to 1,000 kilometers per hour. Current progress, so we're developing today, our main infrastructure project is in Alberta, Canada, where we secured a $500 million investment last year. We aim to start construction of the Edmonton Airport connection in 2024, next year. We're also doing some development in Texas, USA. We had an initial approval last year from Dallas, and we're working at the governor level to increase that corridor to make it, I would say, profitable, economically speaking, to Austin as a first line corridor. And then, of course, Australia, UAE, and Saudi Arabia, we're trying to push the project as well for the project they call the Line or NEOM. You probably have seen that in the news. So, timeline. First demonstrator last year unveiled in Toronto. We're doing all the admin work in Alberta, like construction permit, land acquisition, all the admin work this year to be able to kick off construction next year. We're still in the early phase, so despite the first demonstrator, we still have lots of R&D work to do over the next 3 years. To be ready by 2026, when that first segment in Alberta will be ready. And with that first segment, we aim to 2 years of certification with the authorities. The European Transportation Commission is involved, Transport Canada, Alberta Transportation, and this year we have to involve as well the US authorities to demonstrate or to work with us with the objective at the end to demonstrate that this system is safe to transport passengers and goods. And by 2028, certification, which will give us the green light to kick off the full line, and we expect the full line to be operational before 2035. So that's kind of where we are. Lots of information. I'm expecting lots of questions. Please do at the end of the panel. There's a lot, definitely. And just maybe as a conclusion, this year, one of our objectives is to secure suppliers. That's also one of the reasons we're here. So we're looking at players who master composite for the design and the manufacturing of our vehicles. Thank you.
Thank you, Sebastien. And we will, I know I've got questions to ask, and I'm sure the audience does too, but we'll do that as soon as we finish the other two speakers. So we'll go to our second presenter. Our second presenter is Chart Cypkus. He's the Chief Technology Officer for Ebusco, so an electric bus company.
Okay, thank you.
Based in Belgium. Sorry, based in the Netherlands.
Perfect. We were struggling a little bit with the pronunciation of my name, but that was actually perfect. Thank you. Ebusco 3.0, a game changer in the world of public transportation. And the thing I'm going to talk about with you today is this a compromise or is this actually an opportunity? Okay, a very short introduction video. Actually, when we start designing, when we start evolving our society, we seem to be more and more involved in the environmental part of it. Yeah, the environmental part of it. However, of course, you see on the right side, when accidents happen, we suddenly turn to it should be safe. Then suddenly environment is not that important. And eventually we want to have products that are really nice to use. And of course, then suddenly also we become worried about the cost. So how do we optimize these things? Reinventing the city bus. If we really design our products, we should not design according to the limitations of our designers. We should actually only look at our users, the functions and our users. So that's actually really looking at the passengers, looking at the driver and the operator. And if you do, you will see that you eventually will design a product that is environmental friendly, safe to use, comfortable and cost effective. Seems like a contradiction, but that's not true. I will show you. In this case, for our city bus, we made a few choices. Fully electric, lightweight, of course. Lightweight was just to be more energy efficient. Low center of gravity to make sure that the driver would have a very nice driving bus. Low and flat floor, because people like myself with disabilities, you want the people to get in and out of the bus very easily and have extra wide aisles so that you actually can go in and out. That's what the passenger wants. The passenger does not care about having to step up and sit on high chairs and so on. They just want comfort, but also safety. And if you look at this, and if you look at these choices, you actually make the choices for passenger, driver, and operator. And if you do that, you intrinsically have to design ultra light and ultra efficient. And of course, then at that point, composites does become an enabler if you do this correctly. If you look at the safety side, you think that safety is something that is in crushable structures, but that's not true. If you look at that, if you make a choice for a fully electric bus and you place your batteries in the floor, you suddenly intrinsically get a low center of gravity. You get a better driving bus. If you make it lighter, you get a better driving bus, and therefore, eventually, intrinsically, you get a safer bus. Low center of gravity we already discussed, but also, for instance, a low and flat floor. Can you imagine that if something does happen, you get quicker out of our bus than in other buses? Because the only thing you're worried about when something happens is to get the hell out of there. So intrinsically, if you design a product, you should not design a composite product. Also, like Sebastien just said, it's just, the composite is just an enabler to make sure that you can reach your ultimate goals. And if you do that correctly, you can, and keep your cost under control, you actually get what you want. So just to look at, in this case, our 18-meter variant of our ultralight city bus. You see the chassis where all the batteries are placed. You see the fully flat floor, as I said, with extra width in the aisles so that we actually can get easily in and out of the bus, because that's what passengers do all the time. That's what you design your bus to. The seats, and of course, eventually, the bus itself. So you end up with a product like this. And yes, this is a fully composite bus. Fully composite to make it ultralight. And you see here also the results that we get out of it. It's around 34% lighter than any other currently state-of-the-art bus out there, which takes it for around a 55% longer range. Our standard bus goes 500 kilometers on one charge, basically meaning that it can drive all day without recharging. A lifespan, because of the use of composite materials and the way we've designed our bus, it can easily take 25 years, as standard buses take 10 years. And of course, you have to also look at maintenance cost. Because of the lower weight, there's a lot less wear on all our parts. There's a lot less damage to the roads. So you intrinsically get the whole system is cheaper. And that all becomes part of the choices that we made in the first place. So you see a few pictures. You even see a panoramic window or a panoramic roof, because there's nothing on the roof because all the batteries are in the floor. So you suddenly get a different type, a different generation of buses, which eventually is a game changer in this environment.
Ik ben het meest trots op eigenlijk de snelheid waarmee we deze bus hebben ontwikkeld. En dan in combinatie met de beterslagen die we mee kunnen nemen.
De eerste lichtgewicht 18 meter bus in de wereld dus. Dus daarmee schrijven we echt geschiedenis bij je busco. En daar ben ik trots op.
I'm proud of the growth. I'm proud that we are a young player in the market, but already stirring the market.
Ik ben het meest trots op het feit dat we voor elkaar hebben gekregen om deze bus met behoud van de beschikbare binnenruimte zo efficiënt mogelijk hebben kunnen uitleggen en daarbij een heel lichtgewicht concept hebben kunnen neerzetten.
Dus hoe langer de bus is, hoe meer voordeel we uit ons lichtgewicht concept halen.
I think it's the whole concept. Just to be part of the green evolution, and also to be part of this young team, this new product is amazing.
All the credit should go to the team. They have showed that all their ideas and their expertise came together, and in the short period of time, to a beautiful bus.
safe and lightweight design is an opportunity. So the only thing I can say to you is grab it.
Nice line there at the end, Jack. Okay, and our third speaker before we get to our questions is Jout Nguyen. And Jout is Managing Director of Accor. And, and we're going to switch from, well, I guess at the end of the day, it's still electricity. But in between, you have hydrogen. And so he's going to provide some insights on composite pressure vessels for hydrogen and where he sees the future going there.
Yes, thank you. I guess since you all made it to this corner of the building, you know now what a pressure vessel is. There's never been so many pressure vessels on this show as this year. And what I wanted to show you today is not in particular the details of pressure vessels, but more why do we see so many pressure vessels? Why are certain people among us worried about the carbon fiber supply? And also, if, for example, somebody wants to buy a winding machine today, you have to get in line. But first of all, hydrogen storage, it's not only possible in pressure vessels. I have here a few examples. Maybe in the future there will be more. But why is now everybody looking at pressure vessels today? It's because, of course, it's a mature technology today, but also the supply chain is there. And most of all, most importantly, the framework of standards and directives is there. So for every application, you can find a standard which makes sense for your application. And this is very important because it gives you a certain scope where you can operate with your product. And it gives you a list of requirements which you need to meet to be able to put your product on the market in the end. Now that doesn't explain why on a composite show you see today so many pressure vessels. And for that, I would like to go back to the basics. For me, the basics is university, so I dove into my basement and found a book. It's because I like books, of course. And I went back, maybe somebody knows it, it's the Giran Timoshenko Bible for mechanics. And what do we see here? It's a very simple graph. It's a biaxial stress state in a pressure vessel. But what does this show? It's that in the hoop direction, in the circumferential direction, you have twice the stress in the axial direction. Of course, as we all know composites, this rings a bell and says, okay, maybe composites here make sense, and it does. Beside that, of course, there is the advantage of having fatigue properties, which are usually in composites better than for metals. Now, what's inside a composite tank? The ones that we see today in the hydrogen market are mostly type 4 tanks. Type 4 means it's a polymer liner, which is not load-bearing, and it's covered, it's wrapped with a carbon fiber laminate, or at least a composite laminate. Doesn't always need to be carbon fiber. Then on the sides you have these metal inserts called boss parts, and then there's a valve to be able to shut off the gas flow and maybe also regulate the pressure. Some cases there are dome caps. It's not a strict requirement. It's just in some standards there is a drop test described, and in order to be able to meet it and not have a heavy design, a lot of solutions are found in these kind of dome caps that are attached to the vessel. Looking at the laminate, it's a combination of helical layers and circular layers. And this is where every manufacturer probably has his own philosophy to build it up. What we also see is that for these high pressure, so hydrogen typically 700 bar, you run into thick-walled composites. Easily you can get 40, 50, even more layers in a laminate to be able to build up the structure to withstand the pressure. So thick-walled composites cause some typical aspects which you need to take into account during the design. Now, as for manufacturing, filament winding, it's a very old technique, but it still meets all the specifications that we need to be able to deliver a mass product. The fibers are put in the right directions. It's numerically controlled. And of course, the repeatability is quite high. Now, what does this say for a pressure vessel and in the sense of performance? We see here an example of the Toyota solution where you see where the vessels are situated. Other car manufacturers have other configurations installed in their vehicles. But a very general rule of thumb is that a fuel cell electric vehicle, a typical range 500-600 kilometers, 5 kilograms of hydrogen at 700 bar. Some are able to get some more range out of it, but this is more or less what we're looking at. And then 50 kilograms of carbon fiber needed for this, for containing this hydrogen. This gives already an idea how much carbon fiber is needed for this market. Now, what does the market look like? It's of course the typical discussion between battery electric vehicles and fuel cell electric vehicles. Over these three segments, probably we'll see in the heavy vehicles that there will be more hydrogen electric vehicles than battery electric vehicles. And in passenger cars, it will be the other way around. The expectation in the market is that 2% worldwide of the passenger vehicles will be hydrogen electric in a few years. And the total hydrogen market is expected to be more than 2 million vehicles worldwide. But of course, a vehicle is one thing. You need to get the hydrogen to the vehicle. So there is a certain supply chain before that, which we also need to help out with our pressure vessels. So the related markets, in this case, it's not really ground transport, but we need it. Refueling stations, transport of gas, storage of gas, stationary storage of gas. Basically, you need to have high-pressure vessels to store your hydrogen. And we need the same materials or similar materials as for the pressure vessels that we're using in our vehicles. Usually the standards are different, so the design could be a bit different. But in terms of material manufacturing, it's using the same technologies. To give you an idea, in terms of carbon fiber, what the expectation is today. This is a typical table. I think it's published already several times. Nice to know is that the growth in this product range is situated at the pipes and tanks section. And we see that for now, the global capacity is still okay, but in a few years, there might be let's say, an increase in capacity needed from the carbon fiber markets. So this is, let's say, the reason why there are a few people now getting a bit nervous before running out of carbon fiber for their applications. But I'm sure the market will find a solution, or we're working with the market to find a solution for this. Now, what's the future? I went to my textbooks, as I earlier mentioned. I found back this typical graph for composites. It's all about the interaction between design, process, and materials. Expectations in designs, focus will be probably on reducing carbon fiber content in the products. But also here on the show, we see already some new other concepts for storing hydrogen in tanks. For example, these kind of tubular or S-shaped vessels that are out there. Now, in terms of if processes, it's the market is really scaling up to get this to a nice and robust state. The requirement will be to have better process control, higher productivity, etc. In terms of materials, the focus today is on carbon fiber. The question that we can ask ourselves is, does a pressure vessel really need to be fully made out of carbon fiber? Could we make combinations with other materials that are not out there maybe yet? But the question here is, why do we need such a light design for every application? Voilà, this concludes my presentation.
Thank you, Jout. And we'll move on to the Q&A session for the remaining 18 minutes of this session. Now, anyone in the audience that wants to ask a particular question, raise your hand, and someone will run a microphone over to you. It's not always so easy from here to see who's there, but get your hand up, and as soon as I see somebody moving with a microphone, we'll be able to recognize you. But get started on that as soon as you can. But I'm going to start out first. With the question of I'll start out with a chart about the buses. What percentage of the structure of your bus is carbon versus fiberglass?
I'm not sure exactly about the number, but I think we have about 30% carbon and the rest is fiberglass.
Okay, and which components are the ones that make the most sense to make out of carbon?
All the structural components, obviously, so the window pillars, as we call them, so where, of course, the top of the bus is just a roof which is supported by the window pillars. We have in the front, we have a big composite, carbon composite beam that holds the bus together, but also is for crash, frontal impact damage protection and so forth. Those are the prime components in the bus out of carbon, and most of the rest is glass fiber, just because we need large surfaces but don't need the strength from them.
Okay, sure. And Sebastien, it's more or less the same question with the TransPod, carbon versus glass, and then I guess in your case, I would ask, what percentage of the structural mass of the vehicle is composite?
So we don't have yet the answer to exactly your question. What I can say is that most of the main structure will be in composite. And if we look at the amount of composite we have on new aircraft, such as the Boeing 787 or the A350, I would say we'll have a similar, distribution for our vehicle. The only or main difference compared to aerospace, I would say, type vehicle, is that the environment we're running into is we've removed 99% of the air. So it's closer to the space environment than what we have for airplanes. So we'll need to integrate, like most of the standards we have to apply and follow are coming from the space industry. So if we're using composite material, we'll have to make sure that they withstand vacuum, I would say, environment or low pressure environment, and not like a small amount, but a significant amount. So I don't know if we still need to look today at the different kind of players at the conference, but would be curious to hear from those who are involved in building rockets, definitely, which are what we'll need at the end of the day.
Okay. All right. So we have a question up here, and so a microphone is coming your way. And please stand up when you ask your question.
Thank you.
And announce who you are.
My name is Margaret Slattery. I'm with the Composites Institute. Thank you for your presentation. Given the the great interest in microtransit from many cities moving forward. Are any of you looking at that for your products? Maybe the bus, any of the smaller buses, like the 20 passenger? I didn't know if that was part of your model looking forward.
At this moment, not yet. The company Ebusco is fairly new and is at this moment launching and starting up its production first in Europe and later a worldwide production of our city buses. We have not rolled out the plane yet to very different types of applications yet.
Okay.
Well, I'm not sure it will add more value to your answer, but the only aspect of city or microtransit, the way you maybe refer to, are, for us, it's airport connection. So, but it must be integrated to a bigger corridor. For one basic element is that the airport connection, most of the time, solely is not profitable, economically speaking. So that's why we need a bigger corridor. Also, the main difference to make it profitable, just to emphasize on the economic aspect, we would like not to rely on public subsidies and to be fully financed by the private sector. And in order to do that, we need to maximize the utilization of the infrastructure. And to do that, we're mixing freight and passengers. So within the same tube, you'll have both vehicles transporting freight and passengers. Just to give an idea, on the Calgary-Edmonton line, 60% of the ridership is for freight. And express freight, not maritime containers. Like everything shipped by DHL, FedEx, Amazon. And we'll have to work with those players on how we integrate that within the kind of the cargo transit within the city or between the airport and the city. But we're not intending to. We don't intend to address the last mile delivery. We'll still need some small trucks or other means to do it.
Maybe one small addition from my side. As long as, in general speaking, public transport and especially buses is with a driver on board, you need the maximum amount of passengers behind you to get economically feasible. So the step to more autonomous driving is a completely different step and is almost separate from our basically transferring our current infrastructure and our current public transport into emission-free. As you might know, in 2025, from 2025 onwards, at least in Europe, all public transport, new public transport means should be zero emission, or at least as purchased, and from 2030 it should all be already replaced by zero emission. That's trains, buses, taxis, everything. And which basically means at this moment there's a big demand to make sure that any public transportation means, without being fully autonomous yet, because that is not sufficiently developed yet, will happen. That's currently one of the streams, of course. The next stream is then to go into micro vehicles, but then you have to go to more autonomous vehicles to make sure that you can still afford it. So those are different routes to eventually get to the next stage.
Thank you. So I don't see a hand up yet in the audience. I'm sure somebody is already genning up the next question out there. Yeah, to what all the analysis we've done on composite pressure vessels show that there are really only two levers that you can pull. One is the cost of the carbon fiber, and two is the factor of safety, which determines the amount of carbon fiber used. Are you aware of developments in either of those spaces that could lower the cost of hydrogen pressure vessels and actually, given a certain tonnage of carbon, make more pressure vessels?
I think you're right. So the amount of carbon, or the cost of carbon fiber, and the amount that you need, that's what you can play with. The amount that you need is, of course, determined by the safety factors. But usually, some safety factor is added in a design to be sure that you're never below this safety factor. The safety factor, which you are referring to probably, is the one that's written in standards.
Right.
And this is a safety factor in the sense it's an absolute minimum. You cannot go, if you're below that, you have some business issues, I think. So it means that usually manufacturers do some additional safety on top of that. And this is something that can be reduced in the sense that if you have a stable design, a robust design, and a good manufacturing, you're able to reduce this number and to optimize like that, for sure.
Okay. Chart, have you done analysis, with your vehicle in the, say, the energy or the carbon footprint of the vehicle? How many kilometers you have to drive before that all becomes returned, becomes net zero relative to a petrol or a diesel bus? Or where you can get back to, net zero?
We've not done the analysis in detail, but as far as the general numbers that we come up with, what we see at this moment, especially since we use also some of the fibers and resin that can have a second life as well, that then starts to become part of the calculation that you have to do, is that roughly speaking, within 2 to 3 years, it would return itself, because you have to look at not only the diesel against the battery and the carbon use of the bus body against the any other materials that you use for conventional buses. The game goes even further than that. That if our body life is about 2.5 times what the current body life would be, then you have to take that into your calculation as well. So it's a fairly, before you would agree with say some groups around there whether you've made the right calculation, that is a very complex discussion. The question, I did not include that in my presentation now, I did that last year, is the first question I then had is, if we really want to go to zero emission, should we just continue to use the current technologies and wait until we've solved also the carbon, basically carbon footprint discussion, or should we already make the jump, knowing that you're going to make 90% advantage and solve the other 10% going along the road? And I think we've made that decision to go to make the jump and help to solve the other remaining issues in parallel.
What's is there a price premium of your electric bus compared to the typical diesel bus that might be sold otherwise?
There's two questions. One is, if you compare the price of a diesel bus against an electric bus, the electric bus is roughly twice as expensive. If you look at our ultralight bus against a state-of-the-art traditional electric bus, we sell it against the same price. So if a customer, I think in Europe, especially in Europe and the rest of the world, is I think really close behind. There's no discussion on the fact that we have to go zero emission. So diesel is going to be out. So the question is more, where is the competition? The competition is against traditional fully electric or even hydrogen or ultralight. And I think this is where the real discussion sits, not so much on continuation of diesel. Sure. That's not going to happen.
Okay. So any question from the audience? Make sure. Yeah, we've got one here.
Youssef.
It's on.
Hello. Would like to thank you guys for a very interesting,
Can you put your microphone closer because we can't hear you?
Is that better?
Yeah. Perfect.
Perfect. Youssef Shahabi from GKN Aerospace. I would like to thank you guys for 3 really interesting presentations. I would like to ask you guys, from a sustainability point of view, in terms of the future of ground transportation with composites, do you see it being as one that carries on utilizing carbon fiber reinforced polymers at the rate it currently does? Or do you see more hybridized composite structures being developed that minimize the amount of carbon fiber being used? Thank you.
Yeah, I think that's in line with the question and the answer I just gave. Our first and prime jump is to make sure that we design a bus that is 35% lighter than anything out there in the world at this moment. Just minimizing the amount of energy used and therefore the effective use of it. In parallel to that, we are investing, and I'm for instance also currently attached to the University of Delft, currently in the Netherlands, as we try to develop together with other institutions composite materials and fibers, resins that are reusable, that are maybe more bio-based. That is a part that is going on at this moment. But again, the big question you have to ask yourself, do we wait until that is solved to make the big jump? We said no, we have to make the first the big jump, and in parallel to that, make sure that you continue to develop more sustainable environments.
Yeah, if I may. So you said that you're working for GKN Aerospace. I would love to return you the question. What GKN is doing to kind of develop carbon fibers more sustainable? So that's it's definitely key for us. And we'll look at innovative solutions. We're trying to also to be pragmatic, and we know that it's not going to be easy, but we're looking at that. At a really high level, the system we're doing intend to, I would say, and sorry if there is some airlines in the room, but definitely replace some short-haul flights between, I would say, big cities, especially in North America. So overall, we'll save some CO2 emissions, but we know that our biggest challenge will be to minimize the carbon footprint during construction, and we need lots of steel and concrete, and they are heavy consumer of, or heavy emitters of CO2, and for the vehicle at the end of the day, that's the same aspect. So how can we minimize that? So on the steel aspect, what we're looking is that we know that there's some steel manufacturers who are starting to shift from coal to hydrogen to manufacture steel, which is good. There's some techniques for concrete to produce concrete with, I would say, absorb CO2 and trying to bury it, or anyway, they have different methods. Interesting. Would be really nice to hear from, I would say, aerospace suppliers and fuselage suppliers, composite suppliers, what are the innovative techniques to minimize that? And anyway, so we can give you back the mic if you want.
I think given our time, I think the two of you should have a conversation as soon as our session is over, which will be soon. Just quickly, and I'll just ask you, there's a lot of developments going on with bio-based reinforcements, and I was maybe perhaps for interiors. Is that something you're considering, or do flammability requirements for those kind of modes of transport keep you from using bio-based reinforcement?
For us, safety comes first. So if they comply with existing standards or new standards, fine. But if they don't pass, like you said, that test as an example, we won't be able to use it. Sure.
Yeah.
Now we see also other developments going on, because one of the issues, of course, especially with carbon fiber, is that if you want to take the carbon fiber out of your product and reuse it, normally you almost destroy the properties of your carbon fiber. So there's also developments going on in multi-resin solutions, where you get strength from part of the resin and dissolvability from another part of the resin, where you actually can take the product apart and still have the properties of your fibers left over, which basically means that you can recycle your fibers over and over again.
Ideally.
So there's discussion becomes then, of course, how much do you sacrifice on the strength of your fibers by using bio-based, or so there's a whole scale of developments going on.
Sure, and that's a conversation. I'm afraid we're going to have to stop now because we've hit the time limit. But it's one we can have for hours, I'm sure. Okay, so before we have indeed hit the time limit. There's another session starting in 5 minutes in here on graphene. But I want to again thank all of our presenters for all their interesting presentations. I'm sure they'll be able to meet you outside and engage you in further conversation, and to the Michigan Economic Development Corporation for their sponsorship of this. Thank you all, and enjoy the remaining few hours of JEC World.
Thank you.